Hey, how's it going? This is Kasimwani, and in this video, we will go through a very popular coding interview question um, called longest substring without repeating characters. This is a fairly simple coding question, but is often sort of non-trivial to come up with the solution without any prior experience or knowledge. And if you're new to this channel, I make videos in machine learning. Most of the time it's going through papers and discussing some of that and going through my research in machine learning. And I also make videos on hackathons, projects that I've won. And yeah, and I'll be doing more videos on coding interview questions specifically, hopefully one a week, depending upon the schedule that I have. So yeah, in this video, we'll go through this question where you're given a string and the goal is to find the length of the longest substring without any repeating characters. So when we define substring, it's a set of contiguous characters in the array. So in the case of over here, you have your string ABC, ABC, BB. This would be considered as a substring. This would be considered as a substring. And similarly, this would be a substring. But the letters A, B, and A as a set would be a subsequence and not a substring because they're not contiguous in nature. So the longest substring without any repeating characters are ABC, with length 3, and we're just supposed to return the length of that substring. And in the case of this, it's just 1, which is B. But in this case, it's actually WKE because PWW, W comes twice, WKE, WKEW, W comes twice, KEW, well, that's obviously they're all 3 unique characters. But the first one that we observe is WKE. Um, and so something like over here, um, it's the same example as before, but in this case, it's WKEP, which would be the longest, or KEPW, and that would be 4. So we'd return 4 in that case. So how do you actually solve this problem? It may seem a little bit complicated, but the actual algorithm is quite trivial, but it's non-trivial to come up with the solution a priori. And the way that you do it is through this algorithm known as the sliding window algorithm, which is a two-pointer technique. Essentially, what you do is, let's say you have a string ABC, ABC, BB. I'm just copying the first example. And what you would have is you would have a set of 2 pointers, an I and J pointer. And what you would do is you would solve this through subproblems, essentially. So instead of finding the maximum, the longest set of characters in the entire array, meaning with length, length of this array, you'd find the maximum number of characters that satisfy the constraint with, length at this index and then at this index. So you'd solve it almost like a regular dynamic programming problem, but that's the approach, right? You solve it in batches, you solve it through subproblems. But it's not I wouldn't consider this a DP problem. So the way that you do it is, as mentioned, you would have 2 pointers, the first pointer or the left pointer, and then the second pointer or the right pointer. And what you do is you would have an I and J pointer that would determine the interval of the array, of the subarray. And you would basically, the constraint is that all the characters between I and j should be unique. And if they're unique, you keep iterating j to the right. If they're not unique, then you can no longer iterate j to the right again, because now you've found a repetition in your set. And if that's true, then you iterate the left pointer to the right, because now you know for a fact that the maximum window can no longer be expanded to the right, because you have already observed a duplicate in your current subset. So now you go to the left and you go through the same constraint. Are all the characters in that subset unique? If so, then you iterate the right pointer to +1, and then you continue the pattern. Otherwise, you keep doing it to the left. You keep iterating the left pointer. And that's basically the algorithm. It's actually that's pretty simple once you know how the algorithm works. And there are multiple approaches that you can take. You can actually implement an explicit two-pointer mechanism, or you could be clever and do it in just using a regular for loop and have a defined starting pointer, but have a continuous second pointer, or you could do it using the more traditional, the second two-pointer rule. And so so here's how I do it. So since I said, so the first problem that comes about is, how do you actually determine if all the characters in the set are unique, right? And obviously the first approach you can do is have like a hash map or a dictionary of some sorts. But the thing is that in the constraints, we know that S consists of English letters, digits, symbols, or spaces. And that's basically the entire ASCII table, right, of the extended ASCII table of 256 characters. So we know that the table would have at max a value of 200 or 256 filled characters. You cannot get more than that. And that's what I would do. We would create a set of 256 characters with the initial value declared as -1. Why -1 and not 0? Because the reason for that is because the initial character, before you start the loop, before you start running through the algorithm, has 0 occurrences. So what you could do is, instead of having -1, you could have 0, but then you would do table 0 plus plus, where 0 is the index of the first character. So it would be S0. Right, that's the idea. Or you could just do -1 and save that debugging headache. And when you do have this, so this is technically an auxiliary space of 256 characters, but it's constant. So we can ignore this with just a tiny additional buffer of characters and call this as constant space. And our algorithm, actually, the final algorithm that I'll show you, has a time complexity of O of n, so a linear time, and a space complexity of O of 1, right? So it's constant time. And that's the only auxiliary data that we need, memory that we need. And so what we have is, we have a start pointer, as mentioned earlier, and we have a final, or the right pointer, which let's call it j. So let's actually run through the loop for j in range table. So now we're just indexing through all elements, and j would be the index value. The reason why we're starting with -1 is because every element is -1, and we're trying to have that as a base constraint, which I'll explain, or which you can observe from the code that I'll input. So now what we have to do is, we have to store the character. So the character at store the character at SI and table. And the way we can store it is by taking its ASCII value, and let's call this. Now we can store this, or we now have access to this value, and we know for a fact that this value exists in our table, and by default it has a value of -1. And what we can do is we would check to see if that value is greater than the initial value, which is -1. And if so, that means that we know that there was at least one instance of repetition. So now we know for a fact that this character has been inserted before. Now we don't know if that character that has been inserted before, or the new character that has been inserted, is part of the same subset or a different subset. And if it's part of a different subset, then the normal rules that we talked about, the second pointer iterating, would apply. If not, then we'd have to iterate the first pointer. So what I mean by, so now here's the interesting part. If start, so if table ask would give me basically the count, sorry, would give me the index value, and the index value would be a number from 0 through length s. And that's why I wanted my table to start from -1 instead of 0, because my first value would obviously be 0. So if it is greater than -1, that means that it has already been present in the subarray before. So all I have to do is reset the value start to reflect the value of the current table that's present, and that's it. And after this, so now we have resetted the value of start. But we also have to reset the value of the table that's present, or the in the hash, or in the array. The lookup table would have to reset its value to reflect the value of the current index, and that's j, not I. And once we do reset that value, it's almost like a max subproblem solution being automatically constrained or solved for you. So what you have in this case is when you're at A, your start character is -1. So right before you're at A, start character is -1. Let me actually do this. So your start character is at -1. And your index I is, or j, so second pointer is at 0. But when you do hit A, this becomes 0, and this is still 0. But now when you're B, I becomes 1, or j becomes 1, and B is still 0. But now after you hit B, B becomes 1, and you can see this repetition happening again and again. 2. So when I say start, and so this would be 2. And then right over here, when we hit A again, so in this case, what happens is we've already seen the value of A. So now instead of going to the right again, we would increment the value of A to right. So we now do I++ in the earlier demonstration so that it could go to B. And in that case, instead of it being 0 through C, it would now be 1 through C, or 1 through 2, right? So now we've shrunk the window. And that's what is, so instead of doing that two-pointer method, it gets taken care of automatically by resetting the value at every single point in the iteration. And all we do now is just set the, so we can have a max length constant, that's 0 is what we're trying to return. And we can just do max length equals max. Right. And believe that should be it. Let's run the solution. Oops. Sweet. Awesome. Yeah, so that's pretty much it. It's a very simple problem once you understand the two-pointer or the sliding window logic. And it's only a few lines of code if you actually understand it. The two-pointer method is also pretty similar to this, except you would sort of have to manually control both pointers depending upon their constraints. But I prefer this to be much easier and obviously intuitive, since it's an obvious occurring continuous problem. And that's pretty much it for this video. If you like this video, make sure, yeah, if you like this video, do like and subscribe, you know, the traditional stuff that YouTubers say. But other than that, I'll probably make another video on Leetcode soon. And all right, peace out.